Hello guys, so in this video we're going to talk about how to find the unit tangent vector given a position vector. So we have a formula for the unit tangent vector, which is r prime of t divided by r prime t magnitude. So the first thing we're going to do is we're going to compute the unit tangent vector. The first thing we need to do is we need to compute, for step 1, we need to find the velocity vector, or basically r prime t. So all we're going to do here is just take the derivative. So the derivative of 5 cosine t is negative 5 sine t. The derivative of negative 5 sine t is negative 5 cosine t. And for step 2, we're going to find its magnitude. So the magnitude of this one, all we're simply going to do is add them, square them, and then square root them. So in this next step, what I will do is, all I'm doing now is I'm just distributing the square. And then from there, we apply the Pythagorean identity, because we know that we can factor out a 25, and we're left with the Pythagorean identity of sine squared plus cosine squared. And we know from the Pythagorean identity that sine squared plus cosine squared is 1. So all I did was substitute. So now we can compute the magnitude as well, so which is 5. So now that we did steps 1 and 2, in step 3 what we're going to do is we're going to plug this into the unit tangent formula. So the unit tangent formula is r prime divided by the magnitude of r prime, which we computed in steps 1 and 2. Our r prime came out to be negative 5 sine t, comma negative cosine of t. And the magnitude that we computed was 5. So now what we're going to do is we're going to literally just plug these into the unit tangent formula. So when we do that, we're just plugging in r prime and r prime of t. We get negative 5 sine t, negative 5 cosine t, divided by the magnitude, which is 5. And from there on, we can cancel the 5's. So the 5's will cancel out with the denominator, and what we're left with is negative sine of t, negative cosine of t. And that's our unit tangent formula, or that's our unit tangent vector. So for this example, we're asked to compute the unit tangent vector of this position vector of 5t squared, comma 20t. So we're given the formula r prime t divided by the magnitude of r prime of t. So now what we're going to do, we just do the same step. So for step 1, what we do is we just find the velocity vector. So first thing I'm going to do is I'm just going to go ahead and write it out. 5t squared comma 20t. And we're going to take the derivative to get our r prime of t. And our r prime of t comes out to be 10t. The derivative of 5t squared is 10t. The derivative of 20t is just 20. And for step 2, we're going to compute its magnitude. So what do we do with magnitude? Square, add, square root. So that's exactly what we're going to do. We're going to square the derivative. So 10t comma 20t. And we're going to square each term, and then we're going to take the square root of them. So when we do square, we get 10t squared is 100t squared, and then 20 squared is 400. So now what we're going to do is we can factor out the 100. So we're left with t squared, and then when we factor out 100 out of 400, we're left with 4. And now what we can do is we can take the square root of 100, which is 10, and simplify our magnitude. Thus our magnitude comes out to be 10 square root t squared plus 4. So for step 3, what we're going to do is we're going to plug this into the unit tangent formula. And recall the unit tangent formula is r prime divided by r prime of t, magnitude. And our r prime came out to be 10t comma 20. And our r prime of t came out to be 10t squared plus 4 inside a square root. So what we're going to do now is we're simply just going to plug this into the unit tangent formula. In doing so, when we plug it in, we get 10t comma 20t divided by the magnitude of 10 t squared plus 4 square root. And then from there, what we're going to do is we're going to simplify this a little bit. So we're going to distribute the magnitude to each term separately. So 10t divided by 10 t squared plus 4 comma 20 divided by 10 t squared plus 4 square root. So what we're going to do now is we're just going to simplify this by canceling out and simplifying with the 10 on the denominator. In doing so, we get the unit tangent vector t divided by t squared plus 4 square root comma 2 divided by t squared plus 4 square root. And that's the answer. So that's how we do this problem. In this example, we're going to compute the unit tangent vector of r of t, and this time we have 3 elements instead of 2. So we have t squared comma 4t cubed comma 9t squared, and we proceed with the exact same steps. So for step 1, we're going to find the velocity vector, or r prime of t, and we're simply going to do this by taking the derivative of each element separately. And when we do this, we get our rt is t squared 4t cubed 9t squared, and when we take the derivative, we get r prime of t is equal to the derivative of t squared is 2t, the derivative of 4t cubed is 12t squared, and the derivative of 9t squared is 18t. So that's our r prime. So now what we're going to do is we need to find the other component of the formula for unit tangent vector, and we need the magnitude. So that's what we're going to do. We're going to find the magnitude or speed. In doing so, what we're going to simply do is we plug in each term and we're going to square it. So t 2t squared plus 12t squared plus 18t squared, and we're going to take the square root of that. So the first thing we need to do is distribute the square. In doing so, we get 4t squared plus 144t to the fourth, because t squared squared is t to the fourth power, and then 18t squared would be 324t squared when you can plug in 18 squared in your calculator. And then from there, the next thing we're going to do is we're going to join the like terms. So I put the 4t squared and the 324t squared in green parentheses. Why? Because they have their like terms. And I put the other one in yellow parentheses so that way you can see that they're separate terms. So now that we have that, the next thing we're going to do is I'm going to write this big division line so we don't confuse what we've done with what we're going to do now. What I did in this step was I factored out an 8t squared, because 328 and 144 are both divisible by 8 and t squared, so I factored that out. And from there, what you can do is you can take the square root of t squared, which is t, and the square root of 8 is 8 square root. And then from here, what I'm going to do is I'm actually just going to radicalize this. So 41 plus 18t squared, but then the 8 we can divide it furthermore into 4 times 2. And furthermore, we can take the square root of 4, which is 2, and then the 2 is still inside the square root, and the square root of 18t squared plus 41. So that's the radicalized form of the magnitude. So what we're going to do for step 3 is we're going to plug this into the unit tangent formula. So reminder, the unit tangent formula is r prime of t divided by the magnitude of r prime of t. And the r prime of t that we calculated was 2t, 12t squared, 18t. And the magnitude that we computed was t times 2, or 2t, the square root of 2, and then 41 plus 18t inside a square root. So what we're going to do now is we're simply just going to plug this into the unit tangent formula. So the unit tangent vector is equal to 2t, 12t, 18t, the position vector r prime of t divided by the magnitude. So the magnitude is 2t times 2 times the square root of 2. So now what we're going to do, plus 41 plus 18t squared inside the square root. So now what we're going to do is we're going to distribute the square root to each term, or we're going to distribute the denominator to each term. So 2t divided by 2t square root of 2, 41 plus 18t squared, comma 12t squared divided by the denominator, comma 18t divided by the exact same denominator. So now what we're going to do is we're going to do a lot of simplifying. So a lot of like terms cancel out, and that's why I always highly recommend doing this. Distribute the denominator to each term, so that way you can see the canceling out for yourself. So the 2 and the t cancel out with the 2 and the t in denominator. T squared over t simplifies to t. 12 divided by 2 simplifies to 6. And 18 divided by 2, t divided by t. And when we simplify this, what I'm going to do is I'm going to radicalize. So square root of 2 over 2, and then 41 plus 18t squared inside of square root. So what I did here was I radicalized it. So I know that the square root of anything in the denominator is the same thing as that number divided by itself. So I know the square root of 2 in the denominator is equal to the square root of 2 over 2. And for the next one, the square root of 2 over 2 times 6, 6 over 2 simplifies to 3. So all I'm doing is radicalizing. And if you're taking Calc 3, you should be familiar with radicalizing. So I'm not going to go over radicalizing, but that's what I'm doing. But it's pretty straightforward. And that's the answer. So this is basically how we compute unit tangent. Step 1, r prime of t. Step 2, the magnitude. Step 3, plug it into unit tangent. Thank you for watching. I hope this was helpful. If you thought it was helpful, feel free to like, subscribe, and share. Thank you.